Hello YouTube, it's been a while since I made the last video, but today I'm gonna be talking about connectors because recently some news have been getting my attention about a power connector on a 4090 melting. There are so many people posting it. I've seen some of it on Reddit, on YouTube, mainly on YouTube because J2's hands have been posting about it, testing, trying to replicate the problem and without a success. And this is oh yeah, one thing before we start, this is just what I think is happening and it's a speculation. I'm not saying some of the things I'm saying here is like gonna be what's happening or what's not happening, so I could be completely wrong or it could be what's happening. So yeah, don't go and please just don't go and leave hate comment about how what I'm saying is completely wrong, because there's a chance that's the case. So yeah. And this is not the first time I made this video. So this is the connector in question. There's been all over the place about it melting. Now that I think about it, I forgot to draw something. So yeah, I'll probably just freehand it later. So let's see, this is the connector that's been causing problem all over the place, melting on different graphics card. And it's not a cheap graphics card. It's like a $1,800 to $2,000 graphics card, which I cannot afford. So I don't have the connector. I don't have the card to take the connector for testing. So yeah, this is all speculation based on specs and other things. So this is the power connector. It's called 12 volts high power connector. It's a 6 pair 12 volts, so 6 VCC and 6 ground and 4 signal cable or communication. Right now I'm not sure what kind of communication happening here, but we don't care about this thing right now. We care about the current carrying pins. And this is not the first time as I said before, this is not the first time I make this video. I made a mistake earlier because I didn't do more research. I go based on memory and I thought it was 8 pin. It was 6. No, I mean I thought it was 4 pair. It was 6 pair. So 12 pins. And then after I make that video, I came across a data sheet of the dimension of everything. So there's that. Now here's the thing. This is the spec size of the connector. Yep, it's the 12 volt high power PCB header connector. We don't care about this thing. What's the size of this signal communication line? Oh yeah, it's a 2mm pin pitch. What's the pin size? Let's see. Nope, no 0.30, so half the size of this roughly. Yeah. Now this connector pin, since it's rated for 600 watt, that means assuming that 600 is excluding the power on the PCIe slot, that will make each pair carrying 8.3 amps because 12 volts 600 watt is 50 amps, so 50 amps total all of this. And one thing I just noticed is that this pin size is 0.64 by 0.64. You know what else is roughly that size? This thing. This is an XHJST connector. The pin pitch is 0.54. No, I mean 2.54. My bad. And this is the spec of it. Now, look at this thing. I mean, I know it have a different connector shape, but here's the thing. Right now, I don't know if this 3 amps is the limit from the cable or the contact itself. So I can't really, I'm not too sure about it, really, because it only says 3 MDC 12 gauge. I mean 22 gauge. What's the rating? Yeah, sounds about right. I can't really say for sure if this is cable limited or connector limited, so stop. No, this thing is rated for 3 amps. Though even with all of this thing, so this is 0.64. Where is the, I forgot, where is the pin size? One moment. I know I found the, I know I have the pin size somewhere earlier. Okay, let me pause. Is it continuing? Yeah, it's continuing. Okay, I found the size. Look at this. It's 0.62 by 0.62, so just a little bit smaller than the 0.64 by 0.64 on this connector. And you know what bothers me? This is what is rated to carry. Double the rating of this JST connector, which says 3 amps. I don't know how they do it, but it seems a bit sketchy to me. Now, pin itself is not really an indicator of how much current it can take. It could be this is a cheap connector, so I would assume this is made of like a cheaper material. And I don't know what kind of alloy is used to make this connector, but there's possibility that pin will be perfectly fine carrying roughly 8 amps of current. Again, assuming this is full 600 watts instead of 600 watt including the PCIe, which means it is more like 525. So yeah, I've been looking around about data sheets here. It doesn't show the I don't know, what do you call it? What is essentially this thing? This matters a lot more than you think, because this is what makes the contact with the pin in the socket. Now for signal, it doesn't really matter, because as long as you have good connection, usually just a small pin with gold plated, and you'll be fine for signal, because it doesn't carry any current. It won't heat up or anything. As long as it's a good connection with low resistance, you're good. But for power, I mean, for power you need the same thing, but there's more to it. Now, I don't know how many cycles this connector have, or what's happening in it, but there are so many factors that could cause connector to fail, but with so many of it failing, what I think is happening is the construction of the metal pin in this, which is basically this thing. No, well, there are so many different construction for this kind of stuff, and it matters a lot with what material they use. Now I've drawn some different construction of pins. Not the pins. I don't know what to call this thing. This tiny thing that go. This is the thing that goes inside here. So like here's the pin. When you plug it in, it will make contact with this pin. It's what matters with the connection here. It holds. Now there are 3 common construction method of the connector that I know. I mean, maybe there are some exotic one that I haven't seen yet, but this is some of the most common, for especially for small connectors. The first one looked like this. This is the tiny pin. If you look at it from the side of it. So this is basically a box section of a metal plate that was stamped from a larger plate. It's folded into a box, and then it have a flap that this is the flap that fold it to make basically a spring-loaded contact. So when a pin is inserted, this will make connection. Also the spring, and this spring will push the pin against that. And this is where the cable is crimped to make the connection. And this is roughly what it looks like. Some of them have longer parts here, and the other ones are folded against each other, basically, like, which is what's happening on this one, which I never noticed before. Yeah. Instead of folded into one piece folded, it is cut in half and then folded one after. It's next to one another. And this one is what's mostly used for signal pin. It's simply stamped from a plate. It have a slight bumpy pin that like grab against the connector pin. And the last one look like this, which is what I think is being used in this thing. I don't have a sample to tell for sure what kind of construction is being used. But the benefit of using this is that you have two contact points. While there's a chance this don't really make a really good connection, because there's a possibility this is not perfectly straight. It could be slightly tilted or something, so like it's not fully touching. But the weak side of this thing is that if you, I don't know if anyone ever noticed, but the first time you plug it in, it is tight. But after you unplug that thing and like plug it back in, it's much looser than ever. The same thing as when I did with this earlier. It's quite hard to push it in earlier, but then after I managed to get it in and pull it out, it goes in way easier. And again, the sad part about this is that it didn't show what the construction of the pin looked like, right? Yeah, it didn't show what the bending of it looked like, what kind of contact method, how many contact points does it have on this thing. So this is purely speculation on what's going on. And again, no matter how you do it, I really doubt you can safely run 8 amps through a pin this small, especially with a contact. No, it's not really just the pin size, as I said earlier. If you can somehow make this spring loaded, you can probably carry a lot of current with it, because even with a tiny pin, if you do a solder joint on it, it will carry a lot of current and just warm up slightly. So there's that. Now what I think is happening to this melting connector is that this is what compressed against the inserted pin. So let me draw the pin when it's plugged in. Now this is as seen from above, because this part is on the side of it, on both sides. So if you look at it from above, it's more like clamping it in place. What could be happening is that, as I said earlier, it loosened up, because the bad side of this connector, especially being so small, is that your connection compression rely on the springiness of this part of the pin. And with it being so small, you can't really use a thick material that will be like really springy. So that's a bit worrying. And not to mention, if you plug it in and unplug it so many times, there's also a chance this is bent outwards, just like how some people in the US have, like, they plug in a wall wart adapter and then they let go, it came off. That's basically what's happening. And with it being so loose, there's a lot of resistance in that thing. And not to mention, and with it being so small and a lot of power, this point will dissipate a lot of energy as heat. And as a result, it could be melting the connector. Now, that's one case that could happen. Another issue is that I heard that bending this is like really risky apparently, because this thing is apparently so delicate that I'll guess they have to make it with a really thin plate that was stamped out because it's so small. Just imagine the pin being this small, right? So there's another issue is that I don't think this picture shows the pin still in place, so I don't think it's happening in this picture, but there's a possibility. Now let me draw that because apparently I forgot to draw it. I'm just gonna make a rough drawing. Now this is the rough drawing of a side view of the connector. It depends on the connector. Some of them have a single locking pin or a double or multiple. Now I'll use this as an example. When this is being inserted, the locking mechanism usually it's so small. So it usually have a slightly stamped part of it right here. So it will come out slightly like this. Now what happens when you put it in is that it will go in here. This will be compressed by this wall here. And once it go through, this will open up and get in here basically. Here's where the locking pin will go. So it won't come out. But now we have a really small connector. At the same time, look at the size of the cable that's connected to it. It's huge. Like, what is it, 12 gauge or something like that? What could be a problem with bending that thing is that you could be unknowingly pulling so hard. I mean, you won't feel like pulling it hard, but with how small this part is in here, this could, and I've seen this happening on connectors, even a larger connector. When you pull it hard, this could bend, and so basically what's happening is that this turns to like this, and it gets pushed, and the metal pin that was usually supposed to be ending around the end of this, that's usually around here, will go back here if you just bend the cable slightly, because the bending radius is different on the stacked cable. And if the construction is being like this or like this, what's happening is that instead of it pressing here, the end of the pin could be just right here. So it will leave very little contact point on the connector. Same thing for this. Instead of going to the inside and it's fully compressed on the side and like a lot of contact points, as much as it can get at least. Imagine the pin ends here, and with this, and at the same time imagine with this being loose, you're basically clamping it like this. This will create a lot of resistance and a lot of voltage drop, but I doubt it will be enough to cause crashing. I forgot to silence my other phone. And with it being that way, it will drop a lot of voltage. Now, the thing I would like to try if I have the connector is that I would like to measure the voltage drop on it. It's rated for 8 amps. It's not hard to generate that kind of constant current. I have a buck converter that will happily supply 20 amps continuous to put a load on the connector, and I won't test all 6, but simply all 6 pairs, but I can simply test a single pair since we know what a single pair is rated for. What I'm gonna do is, imagine this is that connector. I will have the socket shorted together and use two cables connected here, and maybe cut the insulation around here because we don't want to cut too close to the pin itself, because with that being so small we could be causing damage to this thing. So we need to be very careful. Cut the insulation around here and short the other end so it's simply direct connection, and then put a 8 amps constant current on this, and we measure the voltage between these two, and with that we can measure the voltage drop the voltage drop multiplied by the current that's passing through divided by 2, and you get how much power does one of the pin dissipate, and you can multiply it by 12 to see how much it actually drops on that connector that creates enough heat to melt all of it. But one thing I just noticed is that what's strange is that the melted pin seems to be on the outside. So the other problem that could be happening here is that either this 2 pin is being pulled out, like what I said here, either that being pulled out, or the power draw is not balanced across the thing. Because I remember Jay have shown the connector with only 2 signal cable, and I will guess that will only pull from a few pins. I don't know how it works yet. I can't really say for sure, but it could be pulling from half of it, because let's see. Jay's new video about the cable from Corsair is, where is that? Where's the part where he shows cable from that he get from Corsair, where, if I remember correctly, I could be wrong, I have to recheck the video, but if I remember correctly, they only have 2 signal pin, and not all the power pin is populated. Where is that? Is it here? Right, silence. Where is that? Is this the one? Is this the one where he get cable from? Yeah. That's it. Where's the close-up look of that cable? Come on, give me the close-up look. Oh, never mind. The full thing is populated. So there's a chance the problem might be it's not balanced. So like some pin will carry more current than the other. Because if the connector is really overloaded, usually what's gonna melt is what's inside, because if all this carry the same current and imagine this is overloaded, the inner pin will overheat. At the same time, the outer pin will also overheat, but then this side will dissipate the heat. So it's not gonna melt so easily, but at the same time, it will also help heating up the inner pin. So like it basically adds to the overheating and cause more melting. Yeah, that could also be the case, because it seems like the outer pin is what's melted. So I wonder if this is caused by, the more I look at it, this is the possible case, or the card trace is not designed correctly, so it pulls more current on that melted pin. I can't really say for sure because again I don't have the card, and I would like to see the voltage drop on that pins. Imagine that. I wonder if there's a difference between all these pairs, because I've seen all previous graphics card is that basically on the board itself this is connected together and this side is connected together on the board, so they're just shorted, but then different connector is separated. So there's a chance this is like split to multiple phase, and somehow this phase pull more power than the inner pin. And it's hard to make out, but it looks like this pin is perfectly fine. Yeah, I can zoom in on YouTube. Great. Yeah, this looks like this pin is perfectly fine. Look at this. And the outer pins are like what's melted. So yeah, that could be the cause as well. Maybe it somehow pull more than 8 amps on here, like more like 10 amps or something. Maybe, just maybe. Because, yeah, oh, look at the pin there. There's a picture of the pin. Show me the picture. Show me the picture of the insert. Okay, so the locking part is on this side. It has side locking part, so okay. That lessens the possibility of pin being pulled back, because with that being two side, it's less likely to do that. But this, wait, 1 2 3 4 5 6. Okay, this is the power pin, and this is the, why do they have so, why is this picture showing so many signal pin? Right now I'm having a hard time figuring out which one is the power pin, which one is the signal pin. Do they show any picture? Do they show any more picture on that? Okay, this shows which one goes where. Let's look closer at it. Okay, so the box one is the power. So this is the power connector. It seems to me like this is constructed like this one, but instead of open at the top, and this is what I draw here, but instead of open on the top, it's a box. It's fully boxed up. So yeah, I wonder how springy is this thing, because the moment you plug it in, it's loose. It loosened when you plug it in the first time. So yeah, it shows this is the power pin. And this is the communication. Yeah, look at this. This is the locking part that I said earlier. Okay, so that's how it is done. What's the wire gauge for this thing? 16 pin. Does it say the wire gauge on this? Connector standard. The maximum diameter of your wire for the power crimp terminal cannot exceed 2.7 millimeter, including the crimp terminal on top of the wire insulation. 2.7 millimeters, so small. The signal sideband is 23 to 26. Okay, that's not a problem at all. It's just signal. For the power wires with the maximum outer diameter of 2 millimeter or less. For example, a very high quality 17 AWG size. So it's recommended 16 gauge. What is 16 gauge? What is 16 gauge at square millimeter? What is 16? 1.5. Okay, so I don't really see an issue with the cable size. But 16 gauge being terminated to a contact this small is a bit questioning, honestly. Yeah, recommended 16 gauge is 1.5 square millimeter and 17 is 1 square millimeter. It's quite a big cable. It's quite thick. And based on square millimeter current carrying capacity, 1.5 will roughly be up to 15 amps. And 1 square millimeter is roughly up to 10 amps. So the safer current will be like 7 to 8 amps. So yeah, that's okay. That's not surprising at all. But yeah, the pin is so small with it carrying up to 8 amps. Yeah, the pin is just too small, I think. And not just the pin, the problem is that there's a contact point with it. Contact point always have resistance to it. I don't know how they decided that it's fine to make that carry 600 watts. Yeah. Please, yeah, this is the graphics card plug, right? Hold on a second. This is a graphics card connector, right? Not the one that you plug into power supply, right? Connector standard slogan. Custom cable guide is 3 millimeter. No wire insertion 7. One sleeve with ringless. Cross sleeve. Yeah, 18 will be way too small because like, what is 18? What is 18 gauge at what square millimeter is a 18 gauge? No, not millimeter diameter. Let's see, what's 18? Yeah, no, 0.75. Yeah, 0.75 is generally rated for up to 7 amps. So be safe. And at 6 amps, I have the same 0.75 cable that's carrying 6.5 amps and it's warm. So it's not gonna be good enough for 12 volts, especially at high current, because the voltage drop will be too much. Removing. Okay, yeah, it didn't really say what it is, but I'll guess this is for for the connection to the graphics card instead of the power supply. Yeah, it's a really small pin with a contact point that it really could be a problem. So yeah, it's all populated, but it's just a power limit that was controlled via software, just like how USB charging works. It's like the charger tells the phone how much it can supply, basically. Oh, like it's not clear. It's not clear. Let's. Yeah, look at that. It's the funny thing is that that's the far out. It's not like in the middle. So either this carry too much current or it's a loose connection. Oh, this one's worse. But look at this. The most damaged one is like not even in the middle. It seems like this is overloaded. Yeah. Oh, who posted this? Oh, look at that. There's a connection inside. There's a chance this is broken, but then now if the problem with this being broken, why is the outer pin the one that melts? That just doesn't make sense. Like, let's take this one for example. If this thing's broke, this pin will be what carrying the rest of the current. Yeah, this will be what carrying the rest of it. This should be perfectly fine if it's if it broke. Unless it broke and just slightly touching. Oh yeah, that could be the case as well. It could be it broke and then being held in place, and this part that where it broke is just touching, creating a lot of resistance. Yeah, that's a possibility. Yeah, that's a possibility that it broke and it causes a lot of resistance. While the voltage drop is not gonna be enough to cause crashing and other stuff, assuming since this is all connected together. But then if hold on. If it is connected together and this one piece broke, this connection will still carry the current just fine. And the thing is, the melting happens at this end, not back here. Like, you'll assume if it's due to resistance at this breakpoint, this area will get really hot. I don't think this breaking is what's causing this thing to melt. Yeah, it's probably the card that's like... It could be the card that's like pulling too much on one pin or something. I don't know if it's the same thing, if it's connected to a single bus on the card or not. I've seen... I just saw Jace2Sense make another video earlier about how this breaking causes melting, but then it doesn't really make sense at all. This is connected together. Like, if this is what's broken, the melting will start here, not this end. And with this being so thin, the conductive property of the metal itself will be less likely to cause this end to melt. It will likely start around here. The melting will likely start around the connector instead of the end of it. So yeah, I don't think this is the cause. This just seems like a coincidence that he pulled it out and it break. The same thing goes for if it breaks right here. If it breaks right here, the melting will start here, not at the end. And looking at the picture, most of the back is just fine. Look at this. It's fine right here. And while this one, it's hard to say where it started because this part is also completely melted all the way back here. But if the break happens here, the melting spot will start right here instead of all the way to this end. And what's probably happened is that this end will be perfectly fine up until here, and then it will melt all around here. It's not gonna look like this. Yeah. I mean, it could be, this is possible that this melts and the plastic fused with the socket itself. So when they pull it, all the plastic gets, like all these plastics that are like coming out here, it gets pulled away. It's possible. But I see look at the color. Just look at this color. This discoloration shows oxidization due to heat. Look at this. It's slightly purple and stuff. It's as if it's been red hot. At least few hundred degrees to change the color. Yeah, look at it. The back of this thing is just fine. I really doubt it's due to breaking at this point. This is likely to be just a coincidence that he's cutting it and then this broke. I think the most likely point is that seeing how flimsy it is, the compression is gone on here. That's a possibility. Just due to how flimsy this is, the compression at this spot could be like weakened and then it's loose and causing this pin, the contact, this point to overheat. Yeah, that's the most likely scenario in my opinion, since we ruled out the possibility of this thing being pulled backwards. This will prevent it from being pulled back. If you pull back one, all of them will be pulled back. Assuming all connector use this design where it's all combined together, that will be the case. And look at that. It gets to 100 degrees. Yeah, look at that. Image builder power connector at mating point. Yeah, see, cables with low cycle and without bend condition have not failed. Yeah, I think this is the problem. The metal being so thin is not enough to hold its springiness. Because even let's take it simply. Look at American wall socket. If you have opened it, I've watched Silver Symbol opening, showing what's inside. The brass plate, the brass inside that forms the contact point is like as thick as this, and it still loses its springiness. The possible point is that this is what's happening. This thing lose its springiness, and with bend condition mentioned, there's also a chance that bending it somehow make this thing even loose, like more loose. Like imagine it being so weak and then you have to bend it and it's open, it opens like this, right? That's That could happen in there. I don't know if it's possible to X-ray this thing to see if that's the case, because I'd like to know. Because as I show on this thing, it could be like when you bend it before, it's only make one contact, and with it being so loose, this contact will be so weak, and it cause a lot of resistance and voltage drop. Yeah, I wonder if it's possible to get my hands on this connector to give it a try. I'll run 8 amps and see if bending it will increase or decrease the voltage drop across it. And as I mentioned earlier, I'm gonna measure it right around here, so not to disturb this pin, and keeping it straight. So like carefully strip off the insulation and put a voltage measuring probe on it. I don't even feel like pushing in a test probe of a multimeter here, because it could somehow bend it in a funny way that cause damage to the connection itself. Yeah. So what I think the case is that, yeah, it's probably loosened up because this material is, with a connector so small, you can't really use thick metal in this. There's no way around that. Like, how are you going to use thick material in this thing when it's so tiny? I don't know who think of this as I don't know who think of it as a good design. I mean, what's the point of making a connection inside the computer so small anyways? Like, we have this, and it never cause a problem unless you're doing it really wrong. Is it possible to see the spring of it? Yeah, I can't see this at all. Even this looks like it's been weakened so much, like it's opened up. It's opened up so much that I can't really see the pin protruding. Let me see if I have a new cable that I haven't used from my power supply. I want to see if it's possible to see the spring from the end of it. I drop this. So here's the big bag of modular cable from my power supply that's on my PC. It's a Be Quiet Dark Power Pro 12. So here's a PCIe connector. Can you see the pin at all? Let me grab a flashlight. I don't see it, but I don't know if I've plugged this in before or not yet. Yeah, I can't really see it. Oh yeah, at an angle I can see it. So based on my analysis, the box section actually opens when you plug it in. Yeah, the box section of that connector actually opens when you plug it in. So let me draw it for you. This is the front look of it. So this is roughly what the front, what what you see when you where's the pivot? When you look at it from this end and you look into it, this is roughly what it looks like. There's a split here, so like when you plug in and the pin comes in, the box section just opens up slightly. But then you rely on simply this part bending to like slightly. Yeah, you rely on this thing bending, and it have to bend back for it to make good connection. And then they also can't really lift so much bending on this thing. Yeah, it seems like that's what's happening in there. Oh, I see how that could be a bending the cable could be a problem. With it opening like this, if you bend, if this connector have even a little play, it could also cause a lever action to causing, like it could cause a lever to open the box section even more. So let's see what it could be look like when it's slightly bent or something, or it's not inserted perfectly straight or whatever. So this will be the top look, like seen from above, where the split is in the middle of it. Oops, that's a bad drawing. So this is what's seen from above. So like the bump will be like, the bump will be inside here, like as seen from above. So the pin will go in like this and open this box section slightly. So what's possibly happening is that if you didn't insert it correctly or some way for some reason, maybe the pin is not inserted perfectly straight, and the moment as you plug this in, it could be slightly bending or something and causing this to be pried open. It's as if you pried open. That's also a possibility on this thing. Due to the design, based on the construction, it is. I can't find a clear image of what the pin looked like. This doesn't show what's the method of joining from there. And yeah, with this thing being so thin, it's also possible that the box is not closing back when you unplug it as it's supposed to be. This actually looks like it's being pushed back. Failure segment and cartridge may not expect bending to the wires. Yeah, I don't really see a lot of information on this. Like they don't. This looks to me like, wait. This looks to be melting. This one is this exact one. It could be like breaking here. Since everything else seems to be fine, it's not melted, but I don't know if this is just a camera effect or something, light bouncing or whatever. It could be that, but this looks like melting to me. And if the melting is here, then yeah, I'll say this broke and it caused loose connection and it gets really hot in here. But yeah, that's all I can really say for now, because I don't have a sample to open or something. Maybe let's open a regular bigger plug. This is an APS power connector. It won't be the same, but it should be close enough. And yeah, I'll be destroying this because it's easier to do that, to open it that way. Just hope I didn't end up cutting myself. Maybe I could just use tweezer to undo the latch that locks it in place. Where's my tweezer? These two pins seems to be constructed in a very similar way. Come on. Yeah, this is not coming out without a fight. Yeah, that's a really strange thing to happen, but like there's so many ways it could happen that you can't really say, oh yeah, this is gonna be what caused it, and this is, and one thing is like, yeah, there's no way it happened that way. It's just, where's my X-Acto knife? Okay, here it is. This is not the proper way to undo this, but like, yeah. I won't be reusing this connector, so I'm fine with removing it this way. Okay, here it is. Oh my god, this is not coming out. For some reason. I'm just gonna push the locking part inwards just so it can come out easily. So yeah, here it is. This is the locking part. It should go out, bend outwards normally, but it's impossible to get it out with that. So yeah, I damaged this thing, but yeah, it's fine. So there are two flaps that opens up to hold this thing from being pulled back. But with it being so small, I can see how this thing could get bent backwards accidentally somehow. Now, since I already removed one of these anyway, let's try to pull it really hard and see if it will bend the way I say it is. Oh yeah, here it is. I get it bent. Let me bend it slightly backwards. Just so it's easier to see. See this? It's a flap that opens up. Is it even recorded? You see this tiny pin? And you see how the other one is bent backwards to the front. And this is like, what thickness is this material? Let's get a caliper to see how thin, what's the thickness of this. And yeah, this is a box section at the end that opens up on both ends. So it's like this, and then when you plug it in, it will open up slightly. So let's see, what thickness is this metal plate? 0.20. And this is a CPU power. I wonder how much thickness you can put on that tiny connector. Let's measure the thickness of this JST connector pin. Oh, it's the same? What? What? Oh, it's roughly the same thickness. Surprising. This is 0.20 and this is 0.19. Yeah, 0.19 millimeter. Surprising. It's almost the same thickness, huh? Is this also 0.19? I don't know. Because I don't have a sample to give that a try. So yeah, I think that's all I can say. The easiest way to try is not by using it on a graphics card like that. Just short out the pin and put loads on the 2 pin. Or well, assuming it's not combined like this. But yeah, if you just short the 2 pins on the ends, it will be like single contact or like two contact, and then you can measure the power dissipation and divide that by 2, so you can find how much power does one pin dissipate normally at 8 amps or something. And then you can try bending the cable and whatever you want to do and see what happens, and see how much power voltage drop increase or decrease, depends on the bending and other things. Might as well even try to like make it slightly loose and something. So yeah, I think that's all there's to it. Oh my god, that's 1 hour of recording. Okay, I think that's all. See ya.